what we're going to talk about here is the general form of the prisoner's dilemma. So the generally accepted form is that a prisoner's dilemma is any game of this form, where we have R, S, T, and P, and B then is the symmetric one, so R and P, and T and S are down there. Now these letters have commonly accepted names. This is referred to as the reward for mutual altruism, for mutual cooperation. This is the sucker. So if someone is being altruistic and the other one takes advantage of them, then the altruistic person is a sucker. This is the temptation. So the temptation to be selfish, and then finally here's a punishment for both players being selfish. Now, that's the general form, subject to a few constraints. So we require that the temptation be higher than the reward, which has to also be higher than the punishment, which has to finally be higher for us to have a dilemma than the sucker reward, the sucker utility. And then finally, there's also that you want this average, that the average utility is worse in this situation is obtained by enforcing 2R being greater than T plus S. And so this is the general form of the prisoner's dilemma. And it allows us to kind of have other values for which we can see and model different things. There's actually arguably a nicer way of writing this down that is kind of equivalent to this. If I move this just over there, and the way to write that down is to go, okay, let's let A be equal to 1 minus mu, 1 plus mu, and 0, with B equaling A transpose again. And so we can just ask ourselves, under what conditions is this an iterated prisoner's dilemma? And we essentially just rewrite this in terms of these with this is a prisoner's dilemma as long as mu is greater than 0, because there we have that the reward is going to be less than the temptation, and the punishment is going to be less than the reward, and finally the sucker is going to be less than the punishment. So a reason for which I say this is a nicer way of writing down the prisoner's dilemma is because you just have a single parameter which essentially reflects everything.